Okay, hi everyone. So today what we're going to do is we're going to look at limits with piecewise functions and also looking at limits with absolute values. Okay, both these things are kind of important and they kind of give us an idea of how what we should be expecting when it comes to limits. Okay, all right, so let's do the easy one first. Now, so limits, oh, sorry. So we're looking at one-sided limits. One-sided limits. All right, so let's give ourselves an equation. F of x is made up of x squared plus 1 when x is greater than 0, and x minus 1 when x is less than 0, okay? And we'll give the 0 to the top one. So let's go ahead and draw this one. For right now, we're just going to draw it, and I'm going to show you that we can find the exact same answer without drawing it. So the top is a parabola. No worries. Here's our 1. We have a parabola from here. That's going to be a solid circle because we're allowed to be on 1. The second equation is a line graph at -1, going up like this. Now that's going to be a hollow circle at -1. Okay, so that's the graph. Some of you might be confused with what piecewise functions are. Piecewise functions are graphs that have a certain lifespan. They only live in certain places. Like fish only live in the water. Do you see fish living on the ground? No, there's a boundary for them. And humans, sure, they can swim in the water, but do they live there? Nope. Birds fly in the air. Humans don't fly in the air. So here's this idea, if you guys aren't quite okay with piecewise functions. The main point of a piecewise function is to pay attention to where do I exist. This is where you live. So the first equation only exists when x is greater than 0. Well, isn't x greater than 0 on this side of the graph? The second part is when x is less than 0. So when x is less than 0, that's the bottom part of the graph. Well, that's the left side of the graph. So that only happens when x is less than 0. So these two different equations don't exist throughout the whole graph, just at certain x's. Now, does this make sense in real life? Yeah, you aren't the same person throughout the whole day. In the morning, you're a type of person. After lunch, you're a different type of person. After school, you're a totally different person. So these types of piecewise functions can model real life situations because it's never always the same equation throughout the whole day. Or circumstances, right? So the right side is, hey, this is when it exists. The left side is what happens during that time period. Oh, after lunch, I'm super happy. After school, I'm super sad. Okay? After I eat, I'm super happy. When I'm hungry, I'm super sad, right? So we're gonna ask a couple questions that happen in this case here. So let's look at some limits. What's a limit as x approaches 0 from the right side of f of x? What's the limit as x approaches 0 from the left side of f of x? Now, since we have the graph, the problem is actually pretty easy. Looking from the right side, what's the y value? Well, the right side, as we are getting closer to 0, the y value gets closer to 1. And hopefully you guys can see as I get closer to 0, my y value is decreasing. It's dropping back down to 1. And that's what it looks like from the right side. But the left side, take a look, as I approach 0, the y value is getting higher to -1. So from the left side, we're saying, hey, this is -1. Now, did I have to draw the equation for this? Now, one thing about limits is you should always just try plugging it in. And if it works, it works. Let's see what happens if I plugged it in here. In the function, my piecewise function here, what happens on the right side of 0? Well, isn't this the right side? So we just plug in 0. 0 squared plus 1 is 1, because that's what it looks like it should be. On the left side, you might say, Mr. Ko, I don't include 0. 0 isn't included. I get it. But what would it have looked like? 0 minus 1 is -1. What happens is limits oftentimes are just plug it in. But which one do we choose? Because which direction are we coming from? Okay. From the right direction, it looks like it's going to be 1, and so does the equation. From the left version, it looks like -1, and so does the equation. So one thing is we don't have to graph it, we just have to understand which way we're going. Now, let me ask you this follow-up question. What would the limit look like as x goes to positive infinity of f of x? Which of these two equations would be positive infinity? Would it be the top equation or the bottom equation? Which domains here would include infinity? Hopefully you're saying that the top one isn't x greater than 0 and infinity is bigger than 0. So we would use our top equation. So infinity, you can think of it as infinity squared plus 1 is a huge number plus 1. Huge number plus 1 is a huge number. That's going to lead us to infinity. It's not bounded. It's going to keep on going. If I ask you the follow-up question, limit as x approaches negative infinity. Well, if I put negative infinity, minus 1, because why did I use negative infinity? Why didn't I use just x squared plus 1? Because negative infinity doesn't fit on the top equation. It follows the domain of my lower equation. So where would I put this piece of negative infinity? Well, that's a lower equation. And if I take a negative number minus a negative number, this is still a negative number, negative infinity. So the idea of limits, doing it without a graph, it's totally reasonable. Now looking here, if I did shoot up to x is positive infinity, you can look at the y value. It does keep on going forever and ever and ever. As I go to the left, the y value dips down and keeps on going forever. It's going to be negative. The more negative my x, the more negative my y. So we say if x goes to infinity, the y goes also to infinity. Okay. Now, that seems not terribly hard, right? Well, let's give us another example here. What if the limit as x approaches 0 of f of x? Let's see what happens to this. Of f of x. And here's f of x. F of x is made up of an equation, negative x squared plus 6x minus 4, and x minus 5. When x is less than 0 and x is greater than 0. So here's our piecewise function. We see that 0 is where everything changed, right? 0 is when everything changed. What happened when you ate that really bad fish? Everything changed. So I'm not going to draw the graph. I'm just going to say 0 here. From the right side of 0, would you be okay to say that the equation is x minus 5 on the right side? Why did I not choose why didn't I say this guy? Isn't that my first equation? But look, that's less than 0. X is less than 0. So this is actually on the negative x squared plus 6x minus 4. That's on the left side, and x minus 5 is on the right side. So what would the graph look like from the left side? As I got closer to 0, here's the easiest part of limits. Just go ahead and try to plug in 0, because that's what it will look like. Plug in 0 and plug in 0, the y value would look like negative 4. On the right side, though, if I plug in if I plug in 0, hey, am I going to plug in 0 to the top equation? No, the right side follows the bottom equation here. So 0 minus 5 is negative 5. So do we have a limit? The left side says negative 4. The right side says 5. Are they in agreement? No. If we wanted to really graph it, we could graph it. But we realize that they don't agree already. So if they don't agree, we can say no limit. So as limit as x approaches 0 of f of x, do they agree? The left guy says it's a rope. The right side says it's a hose. They don't agree. We have no limit. Now we could go and do all the work of go ahead and putting this in Desmos. And it defeats the purpose of kind of just understanding how to solve limits. But if you want to put in a calculator just so you can get some solace that you're doing the right thing, fine, just go take a look. But my point is that you don't have to go through all this work. And then x minus 5, okay? All right. Now, let me do some conditions. Now, for your homework,